Hello everybody, in this video I'll be showing you my project CrisisNet, which was built for a hackathon that we won. So now I'll just go through the problem really quickly. The problem is how can emergencies be detected, verified and communicated early while minimizing false alarms. There's a few statistics here that just show you the problem in numbers, like 40% of UK fire service and 99.9% of the Bengaluru transport system. I will put the data of the Bengaluru transport and the UK fire service thing in the description. I'll also put the code for the entire project in the description so you can run that yourself. I'll also be showing you how to run it and how it works. Other things that we have are like the response timing gap, which is like the current detection delay or the current detection happens in about 3 to 7 minutes, while the critical response window, meaning the optimal time for this to happen, should be less than 2 minutes. And there's reliability issues. You can see that on the screen. So before I go through the solution, I'll just give you a live demo and then I'll show you the code. So when you come onto the CrisisNet dashboard, this is what you'll see. You'll have the statuses on the top right corner with the camera status and the sensor status, which it's still waiting for. And you'll have your sensor data here. So right now, I don't have the hardware with me, so I cannot get real-time sensor data. So what I'll do is I'll create a script that sends fake sensor data. But if you have the real hardware, I'll put an image of the hardware that we built on screen so that you can copy how to build it. And I'll also put the code is already on GitHub, so you can copy that. So I'll run the script now. Okay, so I'm on VS Code, and to run the fake script, what I have is inside scripts, I have a fake sensor.js file that will send me data in 30, like it will send me data that's much high, like the emergency type data in 30 seconds. So I'll just run that. So as you can see, crisis mode will activate in 30 seconds. I'll now go to Chrome and you'll see data will be coming. So the data is coming now and the sensors are all green, which means that the data is fine. What I've also done is I've set up an OBS virtual camera so that the camera that starts up is going to show the screen. So this is the OBS virtual camera that's come up, and now so what I have is I've set up a Chrome window with a flame image, and I'm just going to start the virtual camera on OBS. And as you can see, as soon as that happens, it detects the fire very accurately. It's even following it around. You can also do this in real life with a candle flame or something. I'll be talking more about the model later. So over here, you can see that the alert has been sent. So what alert is this? This is a blue sky alert. Okay, so on blue sky, I have come to the CrisisNet handle, and on this handle, you'll see that there's a post made with an image of the fire, the location of the fire, and also the exact location and a Google Maps link that you can click to get to that location. Now I've blurred it out for now, but if you go there, if you run it yourself, you can actually see it working. So if I click on this, what I can also do is I can send it a message and the LLM bot will respond. So I can ask it like, where is the file? Like, what is the current condition of the fire? And I can send that. So it's going to wait, it's going to send the reply. And now after it sends it, in a few seconds, I'll get a reply from the CrisisNet bot. The CrisisNet bot was almost instant, and it said that the sensors reported elevated temperature and high smoke gas levels. and you can just see. Okay, so I'm on VS Code and I have the CrisisNet project open. Basically, it's a Next.js app with uh, an API that's calling. So I'll start with the hardware. The hardware is just going to like get the data from the sensors and send it to the API sensors. You have to configure this according to your like connection. So if you're running it locally, your hardware and your software have to be on the same Wi-Fi connection. Or what you can do is you can deploy the app on Vercel or something, and or the Next.js app, and then put the real URL so that the sensors are sending real data. And uh, yeah, so that's that. And then it's just getting the data from the sensors, and then it's sending it like it's getting the MQ2, the DHT temperature, the orientation, acceleration, the calibration, and it's sending it through an post request to the API, to the backend of the Next.js app. So that's the hardware, and in the app you can see that we have, in the API section, you have three. You have sensors, fire detection, and blue sky comments. I'll start with sensors. What this is doing is it's just getting the data from the sensors. So the sensor, the hardware sends data to this API endpoint. The fire detection is just the sending of blue sky responses. So once it detects a fire, it's going to send a blue sky post. So it's just sending a blue sky post using this agent from the AT protocol library. And then you have blue sky comments, which just responds to comments. It polls for, it checks for comments continuously. I think it's set up for every 10 seconds. I just need to check. Yeah, so the thing is actually set up for every 5 seconds. So every 5 seconds it checks for a new comment and it responds to that. You can see that in the fire detection. It starts the blue sky comment polling. And the duration in milliseconds just means that this polling thing will continue on for 10 minutes before it will finish. And those are the API routes. And then in page, you just have a crisis dashboard component that is just front end. And what it's doing is it's just polling the sensor data, checking if it's gone above certain thresholds. And if it's gone above certain thresholds, it starts a live camera feed. The live camera feed is from RoboFlow. So a fine-tuned YOLO model is hosted on RoboFlow, and then the live camera feed is given to that RoboFlow model, and it checks for whether there's a fire. If there is a fire, the fire detection route is a post request is sent to the fire detection route that sends a post on Blue Sky. You also, when a fire is detected, it captures the current frame of the webcam, and that is also sent to Blue Sky. So you would have seen that a photo of the webcam is on Blue Sky. That comes from the front end. And yeah, that's basically the entire code. It's just a fine-tuned YOLO model on RoboFlow with a live webcam feed that's being passed to it, and then using Blue Sky for LLM comments. All this code is available on GitHub, and you can run it by yourself. Photos of the hardware are going to be I'll put it at the end of the video as well. That's it. Thank you for watching.